Hi there. So in this first section, section 5.1, what we're going to do is discuss circles. So as I mentioned in my introduction video, what I plan to do here is go through, give some explanations and work through some examples to complement what's already there on your MyOpenMath page as well. Please feel free to use these videos or not. They're meant to be helpful. So here we go. So this first section we're going to talk about is section 5.1, and it's going to be on circles. So in college algebra, we discussed a ton of different functions, but one really important relationship has been left out. And this relationship is essential for understanding trigonometry. And those are the graphs of circles. Now you'll notice that I said relation instead of function, because if we were to graph a circle, we would see that very clearly this is not a function as it does not pass our vertical line test. Okay, so in order to discuss circles, the first thing that I'm going to mention is something that is absolutely essential for trig. And that's our Pythagorean theorem, which tells us that given any right triangle, where C is our hypotenuse, the side opposite of our right angle, we have this beautiful relationship between the three sides of this triangle. And that's one leg squared plus another leg squared is equal to your hypotenuse squared. And this is actually where the distance formula comes from. So for example, if you wanted to find the distance in our Cartesian coordinate plane between 2 points, I'll say this is x1, y1, and this is x2, y2. If we want to find the distance between those 2 points, well, how would we do that? Well, I think you'll grant me this value here on my horizontal axis is x1. This is x2. Up here on our vertical axis, we're at y1. And then right here, we're at y2. All right, so in order to calculate this distance, what we essentially do is we use the Pythagorean theorem. We draw a right triangle. Notice we're looking for the length of our hypotenuse. So we can use our Pythagorean theorem and say, well, it's the length of this side squared plus the length of this side squared. And then we would take the square root of that. Okay, so what is this length right here? Well, I claim that this length right here is x2 minus x1, correct? I mean, this whole distance here is x2, but we're not interested in this portion right here. So we would subtract that off, and that distance is x1. And then similarly, we can find this length here as well. From here down to our x-axis, that whole distance is y2, but we don't want this portion. So we're going to subtract it off, and we know that that distance is y1. So we can say that this distance right here, d, I'll call it d squared, is x2 minus x1 squared plus y2 minus y1 squared. And then, of course, if we want to get d, we would take the square root of both sides. Okay, so this is going to be crucial for how we define our circles. Okay, here's our distance formula. You don't have to worry in this class about memorizing any formulas. You just need to know when and how to use them. So what is the definition of a circle? Well, when we talk about circles, the definition of a circle is essentially it's the set of points that are a fixed distance. We'll call that distance r, away from the center. So here is the center of my circle. We'll call that HK. And we know that by definition, first off, pretend I can draw pretty well, which is an assumption. Any point on our circle is some fixed distance from our center. No matter what point we're talking about on our circle, it's that same fixed distance. Note we call it R precisely for our radius. Well, what is the distance between HK, our center, and any point on the circle? We know that R is the square root, and I'm using my distance formula here. So we know that R is the square root of, well, you take the difference between your X values and you square them. So X minus H squared. And then you do the same thing with your Y values, Y minus K squared. Well, it's not always convenient to have things in terms of having radicals. So I think you'd grant me that we could say that R squared is X minus H squared plus Y minus K squared. Note that R, the square root of this, is my radius and HK is my center. Notice that I'm subtracting in here, and X, Y are just random points on my circle. Again, this is not a function, this is a relation, but it sure is an important relation. So using this formula here, let's do a couple of examples. Suppose I tell you that the center of my circle is at -3, 4, and my circle has a radius equal to 7. Okay, and what I want to do here is just write the equation of my circle given these values of H, K, and R. Well, we have R squared, so 49 is equal to, we take X minus our H value squared plus Y minus our K value squared. Now, the only difference that we would do is we know that minus a negative is plus a positive. So the way we would write the equation of a circle with center -3, 4 with a radius of 7 is as follows. All right, what if we wanted to do the same thing, but now our center is at the origin and our radius is 1? This is a really, really special circle. Okay, this is actually called our unit circle, and it's something that we're going to be referring to a fair amount in this class. Well, putting that in, I'm going to have R squared, which is 1, is X minus 0 squared plus Y minus 0 squared. Notice H and K. So another way we could write this is X squared plus Y squared equals 1. And when you see this, I want you to start thinking about, oh, this is the equation of the unit circle. All right, so now that we've taken our center and our radius and written an equation of a circle, what I want us to do is make sure that we can go the opposite way. So let us take this example here. Suppose I want us to write the equation of a circle, but now I'm going to tell you that the center of my circle is 7, -2. And I'm going to tell you that my circle passes through the point -10, 0. So notice I'm giving you the center and I'm giving you another point that this passes through. Now, I will say this is not a huge thing that we're going to be doing in this class, but this is sort of like stretching before you do a race. We're practicing our algebra skills. We're getting them refined so that we're comfortable manipulating various equations. So let's think about what we have here. We don't know our radius. In order to have the equation for our circle, you can start by writing the formula. We don't have R squared yet, so we're just going to write R squared. We do have our H and our K. I can say that's X minus 7 squared plus y minus a negative 2. In other words, y plus 2 squared. So all I've done right now is plug in the given information. Now, I want to find what r is because that will complete the equation of my circle. What is another thing I know? I know that the circle passes through the point when x is negative 10 and y is equal to 0. So I'm going to plug those in order to find a value for r. So I'll say that's negative 10 minus 7 squared plus 0 plus 2 squared is equal to r squared. All right, so what do I have now? Well, I have negative 17 squared plus 2 squared is equal to r squared. And now we can actually do this computation. If I want to square negative 17, I get 289 plus 4 is 2 squared is r squared. So r squared is 293. So what does that tell us about our radius? It tells us our radius is the square root of 293. But note, we just want to write the equation of this circle. So I claim we have exactly what we need. The key thing to remember is that when you have a number over here, that's the radius squared. All right, let's just do one more example. I'm just going to tweak the information that we're given just a little bit. What we want to do now is we want to write an equation for a circle again. But now what I'm going to do is tell you that the points 2, 6 and 8, 10 lie on the diameter of the circle. Now, if it helps to draw a picture, by all means, I always recommend drawing pictures. That is always a great idea. So that we can get a visual. And I suppose I'll joke and say it's always a great idea as long as you can draw well, which is not always my strong suit, but here we go. So here's 2, 6. And 7, 8, 9, 10. And here is 8, 10. Sorry about this drawing. But this is the diameter of my circle, so it's going to look something like this. All right, well, notice from here, what we want to do is write the equation of a circle. In order to write the equation of a circle, we need to know two things. We need to know what the center is, and we also need to know what the radius is. All right, well, I claim that if these 2 points are on my diameter, remember, the center is the midpoint of the diameter. So if I can find the midpoint of my x values and find the midpoint of my y values, I'll know exactly where my center is. So how do we find the midpoint? Well, it's essentially we're taking the average. So the center is the midpoint here. So 2 plus 8 over 2 is the x value for my midpoint. And then the average of my y values will give me my y value. So 8 plus 2 is 10 over 2 is 5. And here I have 16 over 2, which is 8. So I know the center of my circle is 5, 8. All right. So now what I need to determine then is what is my radius. So thus far, what I have is I have x minus 5 squared plus y minus 8 squared. and I still have yet to find r squared. Now there's multiple ways that we can find r squared, okay? One way to do it is to find the distance using that distance formula from our center 5, 8 to one of these values. Either one works, of course. Another way to do it is just to say, well, we can do what we did in our previous example. We know a couple of points that lie on our circle. And if we plug in either one of these ordered pairs for x and y, that will certainly give us our radius. So that's what I'm going to do for no good reason. Okay, I'm going to take my ordered pair 8, 10. Again, it doesn't matter which ordered pair you pick, same as when you find the equation of a line. Infinitely many points on the line, you better always get the same equation. So I'll say 8 minus 5 squared plus 10 minus 8 squared is r squared. 8 minus 5 is 3 squared. 10 minus 8 is 2 squared is r squared. So we get 9 plus 4, or 13, is r squared. So we know our radius is the square root of 13. But again, in this example, all we were asked to do is find the equation of our circle. And that is precisely what we have here. Okay, just a couple other examples. Again, just to play around and familiarize ourselves with the formula for a circle. And I'm trying to pick examples that are similar to what you're going to be seeing on your homework. So the next example that I'm going to do is as follows. I want us now to find the y-intercept of the circle whose center is 2, 3, and whose radius is equal to 3. Again, we can certainly draw a picture if we would like to, but notice, what do we want to find? We want to find the y-intercept, okay? It's always good to start asking yourself, what is it you want to identify? Notice in the previous examples, I wanted to find the equation of my circle. So that was absolutely the first thing that I would write out, okay? Here we want to find the y-intercept. We know that the y-intercept is the value of y when x is equal to 0, okay? All right, so this is what we're looking for. Specifically, we're looking for this y value. So let's talk about this. What does the equation of our circle look like? Well, we have the center and we have the radius. So it's x minus 2 squared plus y minus 3 squared. Notice that's equal to 9 because that's equal to r squared. Now, just like with linear equations or quadratic equations, when we wanted to find the y-intercept, we would plug in x equals 0 and solve for y. And that's exactly what we're going to do here. To find the y-intercept, remember what you always do is set x equal to 0 and solve for y. So I have 0 minus 2 squared plus y minus 3 squared is 9. Here I'm going to have negative 2 squared, which is 4, plus y minus 3 squared. All right, many ways of doing this, but the first thing that I'm going to do is move my 4 over to the other side. So I have y minus 3 squared is equal to 5. Now, I could FOIL this out, but I know that there's a quicker way of doing it, right? We could FOIL it out and then complete the square or factor, or use our quadratic formula, however we want to do this. But recall, we have that square root method. What we can do is take the square root of both sides. We want to get what's in our parentheses. So the square root of anything squared is itself. The key thing here is don't forget that you need both your positive and negative square roots. So if I want to find my y-intercept, what I can do then is solve for y by adding 3 to both sides. So I get 3 plus and minus the square root of 5. Pretty cool. All right. So one more example that I'm going to do in this section is essentially, it's number 17 in your textbook. You do have some word problems that may or may not be somewhat similar to this, but I would really like to go through it just to be sure, to lay the groundwork, as word problems are certainly something that we're going to be doing a lot in this particular course. So what this question says, and again, it's number 17 at the end of section 5.1, which you can access if you would like to in your book. But it says that a small radio transmitter broadcasts. So a radio transmitter broadcasts in a 53-mile radius. And we are told if we drive along a straight line from a city that is 70 miles north of the transmitter to a second city that is 74 miles east of the transmitter, what we want to know is during how much of the drive will we pick up the signal from the transmitter? During how much of the drive will we pick up the signal? So what I'm going to do for quote unquote simplicity purposes is as follows. We have a radio transmitter. I'm just going to say, you know what? That's going to be at my origin. Okay, we can put it anywhere we want. And we know that the transmitter broadcasts in a 53-mile radius. So I think you'd grant me it goes through 0, 53. Obviously, this is not drawn to scale. 53, 0, 0, negative 53, and negative 53, 0. Again, as I'm going to tell you throughout this whole course, pretend that this is a circle. Okay? And what we're essentially doing is we're starting out about 70 miles north of the transmitter. So we're kind of like at the point 0, 70. And we're driving to a place that is 74 miles east. Okay. So essentially, what we're doing is we're driving this distance, and notice there's a period of time during this drive that we'll be able to pick up the transmission. Okay. Well, what do we need to do? We need to know for how long of the drive we're going to pick up the signal. In other words, we need to find the points where this line for our drive intersects this circle. Okay. Well, the equation of this circle, notice it's at 0, 0. So x squared plus y squared is equal to 53 squared. And I'll definitely be needing a calculator for this sort of example. Calculators are extraordinarily helpful in trigonometry. All right, so here's the equation of my circle. I do need to know what is the equation of this line. Well, I claim this line goes through 0, 70 and 74, 0, right? 70 miles north, 74 miles east. Okay, well, the cool thing is we know the equation of this line. It's the first need to find the slope, and the slope is the change in y values over the change in x values. So what is that? That is 70 minus 0 over 0 minus 74. So my slope is going to be negative 70 over 74. And we know our y-intercept. It's given to us. So I claim this line has the equation 70 minus 70 over 74x. Okay, notice I wrote it as I mixed up my mx plus b. That does not matter. Okay, so again, our goal is to find out where these intersect. Well, if we need to satisfy this equation and this equation at the same time, we know a value of y. We know what y has to be. So what I'm going to do is plug that in. Now, I didn't say this is pretty. Bear with me. So if I have x squared, now I know what y needs to be. Y needs to be 70 minus 74th x squared, and that's equal to 53 squared. All right. This is where it's not as pretty, but don't worry, we can deal. Okay, so what we now need to do is multiply this out, and then we're going to use our quadratic formula. I assure you, you will not have a lot of problems like this. This is just a really good warm-up problem, and it's good that you're seeing me work through this. Okay, so let us go through this. First thing I'm going to do is say x squared, and notice we're in business here really, because notice my only variable now is x. So what I need to do is I need to multiply this out. In other words, I need to FOIL it. So what I'm going to do, essentially 70, there's 1. I'm going to use the FOIL method. You can just use this straight up distributive property as well. But if you multiply your first term, 70 times 70 is 4,900. And then I'm going to do, notice if I do my outside terms and my inside terms, it's going to be the same thing. But if I take my outside terms and multiply them, I'm going to get minus what? 4,900 over 74x. Inside terms minus 4,900 over 74x. And then my last terms, 70 times 70, we know is 4,900, and 74 squared is 5476 x squared. And that's equal to 53 squared, which is 2,809. Hooray! Well, now we get to combine like terms, okay? We have this plus this, and if we want to put this in decimals to get a near enough approximation, that's just fine. You know, having all of these fractions in here might not be very conducive for us. But if I take 4,900 divided by 5476, what I'm going to do is just put this in decimal form. And I'm going to just go to 2 decimal places is good enough. This is about 0.89. Okay. And then 4,900 divided by 74. And then we've got 2 of those. So each of them is equal to about 66.22. All right, so if I combine like terms, I have a 1x squared plus a 0.89x squared. So that gives me 1.89 x squared. I have this plus or this and this to combine. And I will say that is minus 132 if I let it go a little bit further decimal wise and then combine them to two decimal places, I'm actually going to get minus 132.43x plus 4,900 is 2809. Okay, we're through the worst of it. Next thing we do is we are going to get ready to use our quadratic formula. So I'm going to take that 2809 and subtract it from both sides. And if I do that, I am going to get plus 2091. Notice we can use our quadratic formula. And notice I'm using a calculator. All right, so x equals negative b, so 132.43 plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a. Now, what I would do at this point is just do this computation underneath my radical. So I would take 132.43 and square it. And then I would take minus 4 times 1.89 times 2091. And I'm going to get this number right here. And I'm just going to immediately take the square root of it. So 132.43 plus or minus 41.59 divided by 1.89. Oh, 2 times 1.89, which I suppose I should just multiply to get 3.98. All right, well, now we're going to do it. We're going to take 132.43 plus 41.59 and divide that by 3.98. And we're going to get x to be 43.72. And then I'm going to do the same thing, but now I'm going to subtract 132.43 minus 41.59. And then divide that by 3.98. And I'm going to get x to be 22.82. Notice I got two x values, but that makes entire sense. Well, here's the deal, my friends. If we're going to find the distance between these 2 points, and we know our x values, so 22.82, we need to find the corresponding y value, and we need to find the corresponding y value for this ordered pair as well. Okay, how will we do that? Well, we know that they lie on the line 70 minus 70 over 74x. I think you'll grant me if I plug in my x value, I should definitely get a corresponding y value here. So for example, I can plug 43.72 in there, and I can do this as follows. So I can take 70 divided by 74, and that's negative, times 43.72, and then add 70 to it. And I am going to get, let's see, sorry, 70 times 43.72 divided by 74. I'm going to get, for this one, y is 28.64. And now if I plug in 22.82, I'll multiply that by 70, divide that by 74, and then I'll add 70 to that. And I'm going to get y to be 48.41. All right, well, now I have my two ordered pairs. I know that between 22.82 and 48.41, that's where I'm going to start having reception. And I'm going to finish having reception at this point. So what we're going to do now is find the distance. What a ball, huh? So it's the change in X values squared, and then the change, 28.64 minus 48.41 squared. And not that we really necessarily care what the answer is, but I certainly wouldn't want us to be up all night wondering what it was. So I will do the computations. So if I take this first value, I get 436.81. I already subtracted and then squared it. And now I'm going to take 28.64 minus 48.41, and I'll square that. And I got 390.85. And so now I can do my computation. I'm going to add these two values together. And then I'm going to take the square root of it. So I'm going to get a distance of about 28.8 miles. All right, don't worry, you're not going to have hugely complicated ones like that, but I think that they are really useful to go through. And again, this first section is just an introduction to circles, and my hope is that these examples were helpful for you. Thanks so much.